Hey y'all, in this video we are going to go over an example problem of a projectile being launched at an angle that goes below the horizontal. So in this problem we have a ball being launched at 20 meters per second at an angle of 30 degrees below the horizontal. And it's off of a cliff that's 50 meters high, and we want to find how much time it takes the ball to travel for and how far does the ball travel horizontally. So first, to start off with, let's draw a picture of what's going on. So we've got our cliff, we've got our ball being launched, and it's going 30 degrees below the horizontal. So that means it's going to go down like this to the ground, right? And then this, it would be 30 degrees right here, because it's below that horizontal, that if the ball was just being shot horizontal. And then our initial velocity that it's going is 20 meters per second. So it's going down this direction, 20 meters per second. So that's a nice visual of what's going on. So let's go ahead and create a table of the variables that we know to begin with. And we know that for this, I always set up the table in X and Y. We don't know everything, but it just gives us kind of a good start over what we have. So we know to start off with, we know our accelerations for the horizontal for these problems, unless told otherwise. Your horizontal acceleration is 0 meters per second squared, and your vertical is negative 9.8 meters per second squared. For our displacement here, we don't know the horizontal, but we do know the vertical because it is on a 50-meter high cliff. So this height here is 50 meters, but our ball is traveling to the ground. That's the negative direction, so it's going to be, our displacement will be negative 50 meters. We don't know time, we're solving for that. And then our initial velocities, we know the initial velocity of the ball at this angle, but we want to know it in the horizontal and in the vertical. So let's go ahead and break that down by using our two trig functions. So our horizontal initial velocity, that can be found, that is this component right here. That can be found by doing Vix equals Vi. And since that side of your is adjacent, it'll be cosine of your angle. And so that would be 20 cosine 30. And that is going to equal 17.3, and that'll be meters per second. So then that can go in our chart here. And then for the vertical velocity, that is this component right here of the triangle is the vertical. So that's going to be our initial velocity times sine of your angle, because that side of the triangle is opposite. So it'd be 20 sine 30, and that will equal in the calculator 10 meters per second. Now, that 10 is going which direction? Normally, we haven't really dealt with this because we're firing things up into the air, but now we're firing them down. So this 10, we're actually going to make it negative because it is it's going down here, and we consider down the negative direction. Just like we made this 50 negative because the ball is falling down, we're making this 10 negative. We'd keep it positive if it was going up into the air, because up is positive, right? So I'm going to go ahead and make this negative for the chart so that when I need it later, I don't forget to do it, okay? So now this is everything we need so we can actually get started on finding the time. So let me scroll up here, oops, if it'll let me. And we can find the time. This is going to be similar to the previous example where we ended up using the quadratic formula. So to find time, you are going to use our distance formula, and we're going to use the vertical information because we know more in the vertical. We go back to this table, we know 3 things here versus we only know 2 right here. So it makes sense that we need to use the column that has more information. So we're going to use our distance formula, which is our vertical displacement equals our initial vertical velocity times time plus 1/2 times our vertical acceleration times time squared. So then we're going to plug in what we know. We know our vertical displacement is 50 meters. Our vertical velocity was negative 10 times time, which is what we're solving for, plus 1/2 times our vertical acceleration, which is negative 9.8, times time squared. Okay, so from here, we need to use the quadratic formula because we have time in two different places. So I'm going to rearrange this to make it easy to identify what A, B, and C are for the quadratic formula. If you're really good at math and you can do this without rearranging it, great, fantastic. Just be careful doing it that way. But for those of you that I know are probably watching this and confused, we're going to rearrange. So we're going to start off by bringing this 50 to the other side by adding it over. So that on the left-hand side, we get 0, which is what we want. And that is going to equal negative 10t. And then we're going to combine those 1/2 and the negative 9.8. So it'll be minus 4.9 t squared. And then we're going to add the 50 to the end here. So we're almost there for the format we want, but not quite. So we're going to rearrange we're just going to flip the places of the t squared and the t. And because we want the t squared first. So this is going to be 0 equals negative 4.9 t squared minus 10t plus 50. And now we're in the format that we want for the quadratic formula. And the number with t squared is A. The one next to just a single t is B. And then the last one is C. So now we can go on to the quadratic formula. So our quadratic formula is going to be time equals negative b plus or minus square root b squared minus 4ac over 2a. So we're going to plug in for negative b. B is negative 10, so this is just going to turn into positive 10, plus or minus b squared, so negative 10 squared minus 4 times negative 4.9 times positive 50. And then that will be divided by 2 times negative 4.9. All right, so next I'm going to just simplify everything. I'm going to simplify what's underneath this square root. So I'm going to 10 squared plus square root of 1080. And then I'm going to simplify the bottom down to, when you multiply that, you get negative 9.8. And then I'm going to just continue to simplify this down by square rooting that 1080. And I'm going to have now 10 plus or minus 32.9 over negative 9.8. And I'd recommend doing this and then doing that plus minus option. So you have two options here to either add or subtract. So 10 plus 32.9 divided by negative 9.8. That is going to get you a negative 4.4. And then if we do the subtraction option of 10 minus 32.9 over negative 9.8, that is going to get you a positive 2.3. All right, and this is time, so it's in seconds. Now you've got two options, and we want the positive option. So we're going to pick 2.3, and the negative option is crossed out. What this negative option is actually in reality is when you have this quadratic formula, we're only looking at a portion of the curve here. But if this were to be launched from the ground and it goes up and hits and then starts coming back down, it would be the time from the ground up and over to this point. What that other number is, which is why it's in the negative. But we're only looking at it from here forwards, which is the positive side of it. So that's where that other number really comes from mathematically, and we're not technically arbitrary, just like canceling it because it's negative. It is the other half of the parabola here. All right. So anyway, that is, if I can, that is our time is 2.3 seconds. So we can add this to our table here of 2.3 seconds and 2.3 for both columns, because it's going to be the same time that it goes down and over. And we can move on to question 2, which is how far does the ball travel horizontally? So what we're looking for here is we're looking for this range that it's going to go. We're looking for that. Where's it going to land? How far away from the cliff is it going to land? All right, so this one's easy. It's the distance formula, but now with the horizontal information. So our horizontal displacement equals our initial horizontal velocity times time plus 1/2 times our acceleration in the horizontal times time squared. And if you're good at this, you don't even need to write the second half because you know it is going to be gone because your acceleration is 0. All right, so our initial horizontal velocity, if we go back up, we saw that we found it earlier to be 17.3. meters per second. And then our time we just found was 2.3. And we're just going to multiply those together. And we are going to get an answer of 39.8 meters. And that is how far the ball is going to travel away from the cliff. And we're done. So I know this is a lot to take in. If you're still lost or confused, just reach out and I'll be happy to help.